So I have the windmill ready now for a initial test. Have the RPM sensor right here, Hall effect sensor, and the magnet that goes along with that right here. So that's like a switch that turns on and off as the magnet passes by there. So I want to check that out to see if it's working okay out on the tower. I think I have all the screws and nuts and bolts tightened up. Also I have a stop here so that the furling of the rotor is limited. I'll try to do that here. Like this. Comes up against that rod, so that limits the degree of furling, and with luck will keep the blades of the rotor from hitting the tower. This is a new rotor. I ordered a new one after the last one pretty well self-destructed. I'm using the bearings that came with this new rotor. They're not great bearings. You can feel a roughness when you rotate them with your finger, but I'm going to give them a try, but I'll keep a close eye on them because I do have replacement bearings that I think are better quality. Everything got kind of bent up in the first two runs of the machine. You can see this tilted down right here. I believe the rod in the hinge itself even got bent and twisted a little bit. So I'm leaving it as it is. I've replaced the spring mounting bar right here with a different one, and that also serves to mount the RPM sensor there. So I believe we're ready to set it up. I'm going to leave it up and give it a try to check the RPM sensor, but I don't think we have enough wind today from the right direction to give a test of the furling action. So I will likely bring it in until I see good wind coming, because we have a lot of icing lately and I don't want to have complications for the initial testing. The goal is to see if the incorporation of the furling mechanism will give this decorative type of windmill a chance of surviving in the high winds that we get around this area. One concern I have, and I'll have to keep a close eye on the cable that connects the sensor to the inside of the house where the display is. This is the cable right here, and that will go over a snowbank into the house to connect with the display. I'm concerned with the yawing of the windmill and the winding up of that, because I don't have any sort of slip rings on that. So I'll be keeping a close eye on that, so I will unwind it as required. So the magnet that's mounted on one of the blades, it doesn't appear to put any imbalance in the blade. The blade seems to be pretty well balanced with that on there. And also for now I'm trying to use the magnetic force alone to keep the magnet in place. If that slips with higher speed rotation of the rotor, I'll have to epoxy it in place. I'm trying to install this now and give it a run. I'm primarily interested in testing out the RPM sensor and the display that's in the house and see how that's working. So I'll get it installed and get that checked. So I notice there is a little bit of wobble and vibration there at the. So now I'll go inside and check and see if the signal to the display is working okay. So the indicated RPM at the moment is 340 or so RPM. The wind is, according to this wind speed reading, is around about 12 kilometers an hour. That refreshes every minute or so, so it's not a great anemometer display at the moment, but that's what I have. So the RPM meter and sensor are all working fine. Wind speed is not high enough to cause furling action of the windmill. Right now the wind speed is about 21 kilometers an hour, and the RPM of the rotor is about 400 RPM. So the RPM meter is indicating 0, even though the windmill is spinning freely there. I have no idea what's going on. Possibility the magnet slipped from its location on the blade, so I'll check that out. So I just brought the windmill back inside after its initial run, and as I suggested, the magnet did disappear, slid out of place and flew off, I guess, with the centrifugal forces there. So that's a simple fix, but I'll be using epoxy perhaps to secure that in place for the next run. So for the first test, which was intended primarily to check the RPM meter, sensor, and so on, and it worked just fine. The maximum RPM I observed in that short test was about 800, and I'm assuming therefore that magnet flew off in that speed range. I'm not sure about that. So I epoxied on a new magnet. You can see right there. I have the epoxy covering the entire magnet to prevent breakdown of the coating on the magnet. So when I installed that, I did get some imbalance with the rotor, so that's what I'm experimenting with now. And I'm using magnets to help me find a balance. Right now it looks like I have a fairly good balance there. And I'll substitute something else now of the same weight and roughly the same location before I give it a test run. Not perfectly balanced, but it's fairly good. The real test will come when it's in operation in the wind. So here I'm setting up an experiment to see if having the accelerometer display will give me a better idea when I get the rotor balanced. So I'm going to try different weights on the blades of the rotor and spin it up, hopefully outside. Maybe there's enough wind out there today to spin it up while it's on my workbench right here. So we'll see how that goes. So I just reduced the sensitivity there of the accelerometer. I think the bearings on the rotor are not that great. They tend to make a fairly disturbing sound, let's say, when the rotor slows down, even though the rotor's only been in operation probably an hour or so. I have a magnet temporarily on one of the blades in an attempt to balance out the weight of the tachometer magnet. I can see vibration there now, even with the balancing magnet in place. So it might be a bit tricky getting it totally balanced, which is not unusual for something like this. Probably doing about 300 RPM there now. The stroboscopic effect quite significant, so you can't tell perhaps from the video what the speed might be. So my objective is to get the turbine up on the tower, look at the wind speed and the RPM, and hopefully in this set of tests we'll get wind sufficiently high enough to cause furling of the turbine slash tail mechanism, and to confirm that the overspeed mechanism is working or not. You see the tower out here. The anemometer, there's two anemometers actually in place. You can see one on the left, there's another one on the tower. Turbine will go right there. So the turbine just installed a few minutes ago, and we're getting a reasonably good breeze out there, as indicated by the turbine RPM and the wind speed. The wind speed is in kilometers an hour. So far I've observed the turbine rotating a little bit past 900 RPM. Not sure what wind speed that occurred at yet. Get a fair stroboscopic effect there on the blades, so at times they look like they're not rotating or barely rotating, but at the moment, for example, close to 800 RPM. So the turbine now has been running quite successfully for the last little while. The maximum wind speed predicted today at the airport, 60 kilometers an hour. I haven't observed wind that high speed here yet, and I may not get it at that particular hub height. But anyway, I'm going to secure the rotor for a while and hope for higher wind speeds a little bit later on. So we have quite a bit of icing built up on the windmill and tower and wires and so on this morning. I have the windmill disabled for now, waiting for a good strong wind to check out the furling action. The anemometers are all stopped today. A lot of icing on my wires there.